Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Tufin. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of the discussion or you would just like to share it with a friend, the on-demand recording will be made available after today's webinar concludes. So if you look at the right side of your screen, you'll notice a Q&A tab. This tab is where we want you to send in any questions you might have for Ricky today during today's discussion. And if you just have any points of conversation to add, or you just want to tell us where you're tuning in from, please direct those comments to the chat tab located right next to the Q&A tab. And finally, at the conclusion of our webinar today, we will have a giveaway for 4 $25 Amazon gift cards. So on to our presentation today. Our topic is DevSecOps Best Practices, Automating Kubernetes Network Security Policy. And I'm joined today by Ricky Egge, Solutions Engineer, Team Lead at Tufin. And it is my pleasure to turn the floor over to Ricky at this time. Ricky, thanks so much for being with us.
Thank you so much, Cody, and thanks for the introduction. I see a bunch of hellos in the chat. I will tell you hello from Minneapolis, where it is a balmy negative 18 C or negative 18 Fahrenheit this morning, which is roughly negative 22, 23 Celsius. So it is really cold. So we are all staying indoors. I will actually kind of jump in and give you a little overview of the presentation here. So we'll start with slide number 1, actually. Again, this is reducing risk by automating Kubernetes security policies. The idea behind this is to be able to actually provide a language from your developers and your security analysts and engineering teams to be able to work together to build security policies for Kubernetes, not just vulnerability scanning or code scanning, things like this, but the actual network policies to understand what can talk to what and who can talk to who within your Kubernetes clusters. So we're going to get into a couple of things, looking at actually gaining real-time visibility into your east, west, and north-south traffic. So understanding what's happening intra-cluster and what's happening outside your cluster where you have other external dependencies that you need to reach out to. Actually going through designing those Kubernetes security policies, and then accelerating code promotion by including your network policy in your automation pipeline. And then we're going to walk through those, and then we're going to look at a live demo of all of those different things to be able to see that information. So the first thing is gaining real-time visibility into your Kubernetes traffic. This is one of the big things. My background comes from security engineering and network engineering. I've been working with cloud and Kubernetes and stuff like this for many years, but it's not my native way of doing things, right? So for me, understanding Kubernetes, it helps a lot if I can visualize things. And this is something that I find is one of the things that's kind of lacking in a lot of the tools. And it's being able to actually see what is actually communicating, where is it communicating, and what are its dependencies, so that I can actually determine what's an appropriate security policy. So being able to get that map and that picture of where you're talking and what you're talking to is hugely important to success. And once we get that information, being able to then actually see it, and this is something where you go, from a developer, you're used to looking at your network policy, YAML files. Me as a network and security guy, I'm used to looking at firewall rules. And what this does is it allows you to actually take that network policy and lay it out in a source destination port format that your security analysts are used to. So you're actually able to speak a common language and understand what's going on. When it comes to designing the security policies, the old way is the YAML file that you're creating by hand, and you're hoping you have everything included. And a lot of times what happens is if something's not working, what do we default to? We default to, well, we're going to allow everything because we don't know what's breaking, and I'm trying to figure out why it's not working. But at this point, I just need to get my job done and move forward. So I'm going to set it to everything. Well, the new way actually takes a look at that, understands what's trying to communicate within that cluster. It actually gives you a list of all of the ports and protocols that are being attempted so that you can determine, is this appropriate? Is this not appropriate? And you can talk to your security teams who are familiar with what those new risks and vulnerabilities and things are that they need to be mitigating against. So you can understand, maybe I need to change a port and protocol. Maybe I need to change the application somewhat, and being able to take that information and then act on it and build a policy together in collaboration, as opposed to in a vacuum like we did in the old days. Some of the other things that we look at is what can we do to accelerate code promotion. So one of the things that we do is we actually have some Jenkins plugins out there that allow you to do things like integrate your vulnerability scanning into the process, integrate downloading of that new network policy YAML file into the process, and being able to check that into Git and actually turn that into security as code. So we'll get into a little bit of that. And now we're going to go from here. We're going to jump right into an actual demo of the system and what this looks like. So I'll go ahead and turn the slides off here, and we're going to go to a Chrome tab, and it will be the Tufin Secure Cloud Chrome tab. What I'm going to do is go right to that first portion of this, which is the map that we had talked about. You'll see I have a couple of clusters. I had a retail cluster and a My Project cluster in here. My Project cluster is not connected. I don't have the script running in it to be able to connect it to Tufin Secure Cloud, but I do have my retail cluster. And right now I have it sorted by namespace. And as we zoom in, you'll be able to see whether, there's the default namespace and what it's talking to, things like this. I want to actually see the individual container. So I'm going to turn off my grouping and go to none. And I'm going to then turn off all of my namespaces and actually get just my user defined. So I'm going to pick up, in this case, default and data, a couple other cube system ones in there. So now I can actually take a look at my application and actually see, all right, I come out from the internet now, I come into my cluster, and I have a couple of containers that are exposed. I have an admin container, I have a customer container here, and these are the two portions of the application that are exposed externally that I'm actually able to reach. So if I go ahead and I'm going to stop the share and actually jump into each portion of that application here, and we'll share the screen. And we're going to look at the admin portion of this. So when I look at the admin portion of this, you'll actually see that I'm pulling up a couple of things. I'm pulling up, a generic bank, and I'm able to pull some time information. I'm able to go through and view accounts within here, things like this. If I look at the customer portion of this, and I'm going to just share the customer portion. And what you'll see is I have a really generic portal here. So it's, as it says, generic bank, right? So I'm going to go ahead and sign up, and we'll call it demo RE03, then time RE. And we'll go ahead and create that account. It gives me an account ID in here, which I really don't need. I'm going to go ahead and log into it. And it's going to give me a bunch of, I'm glad I just opened this account. I have a couple $100,000 worth of investments and savings and checking. So I'm not doing too bad. When we look at this, it's a pretty simple app, but what it does is it gives us the ability to actually go through and then take a look at what's actually happening within the slides themselves. So if I go to I'm going to actually share just the window here and go back to the Kubernetes cluster, and what you're going to see is that I actually have all of these different items in the map now, and I'm going to go ahead and refresh it, and I'll actually see that I have some new connections that have been built in here. I'll see that my customer is talking to a Retest database, customer is talking to the balance. I have indexers talking to Retest as well. Time is talking out to the API.timezone.db. Admin is talking to time, and then time is also talking to an internal time server on the same port 80. So I'm actually able to start pulling this information and understand what's going on in here and be able to say, are these new connections that I didn't know about previously that I had my any policy? Are these new connections something that I should be aware of? And should this be included in my policy? So I know that I need to be able to have my admin time. I know I need to have my time servers in here. I know my indexer needs to talk and my customer stuff. Those are all important. I'm going to go ahead and add that to my security policy. From there, what this does is it then gives me this whole view of all of the different portions of my security policy that are within this cluster. I'm looking at all namespaces right now. I don't want that. I just want my data namespace and I want my default namespace. I'm going to go ahead and filter on those. And now we see that I have customer Redis and all of these portions of this. This is that text, that giant YAML file that you're used to that is kind of questionably human readable. It's now in a very human readable format. So you can see each individual source, destination, and port and understand what's going on. If we know something's coming that I need to add a rule, I can go ahead and do that. I can select the namespace. I can select the destination namespace or pod or workload or domain, any egress anywhere, etc. So you're able to actually go through and build this out. So you can enter individual ports and protocols as necessary and add descriptions to turn this into information that you need, right? You can actually go ahead and edit rules and add comments in here. So if you want to leave something, leave a note in here. I know this is customer to Redis. I'll just go. And we'll just go ahead and throw a note in there. And now I actually have information in here to start documenting what rules are for. Maybe I document rule owners, things like this, who's responsible for it, so that when I come back and look at this, I understand some of that historical information and what goes on. We have a few options here as well. We can view new connections in here. We can add rules. And then the big portion of this, export network policies as a YAML file. So previously, when you were handwriting this YAML file, it was very error prone and it would cause problems. So what we're going to do is stop this share real quick. And I'm going to share the actual YAML file that we're looking at. So when we look at this, this is the big YAML file that we're talking about. So you'll actually see that it gets in here, talks you through how to actually apply that YAML file, shows you how it was created, what account it came from, etc. But then it actually gets into the network policy details in here. So when we looked at things, the ingress is the, default admin port 80. The destination is the Postgres app, and this is a policy, right? So it's actually going through each line in that policy, and it's turning it into the individual sections of the YAML file that you apply out to your Kubernetes cluster. So there's that kind of portion of that. When we look at what other things are doing here, this is usually something that's time consuming and very error prone. So being able to agree on it, automate it, makes it really nice. And there are APIs that I'll get into here in a few minutes that actually walk you through this portion of it. Some of the other things that we do pull in besides this is things like your admission controllers. You're able to see those things and see why they're in here, etc. So all of the different admission controllers that are a part of it. You're able to see the default network policies. So the policy names, the target, the sources, destinations that you have when you build the cluster. You'll actually see the different nodes in the cluster. You'll see in this case, I just have a single node, but it's got a lot of different labels associated with it. You'll see the actual workloads themselves within here. So you'll actually see each workload, the pod details with the, in this case, the app that's running on it, the container image. And then you're going to see this grade associated with it as well. And what this is doing is it's pulling in that vulnerability scan information. So it's what in this case, we're using just Claire, the open source vulnerability scanner. It could be something from Palo Alto. It could be, StackRox, whatever you're using to vulnerability scan your systems. It's going to pull it in there, but it's also pulling in some of the security context information, like a writable root file system, whether you have privilege escalation available in here as well, whether your memory is unlimited. And it's giving you all of this information. And if we actually drill into the container itself, this is where it's pulling in those vulnerabilities. So you can see your high, medium, low vulnerabilities in here and see what the different portions are. And this is where actually having a Kubernetes security policy within the cluster becomes important. Because if somebody does get into one of your containers, can they escalate those privileges in that container and move laterally to other ones within your infrastructure? And what can they talk to you outside of that as well, right? So that's really giving you that information. And then we also get into the services. So you're actually able to see the endpoints that are exposed. So you'll see my admin endpoint, my customer endpoint, the account and balance endpoints in here that are part of each one as well, and how they're exposed, what ports and protocol that they're exposed on, and then the pod labels associated with it. So we try to give you that visibility that's necessary to be able to build that security policy and to make an intelligent decision on what you should be allowing. When it comes to actually deploying this, it's a pretty straightforward deployment in here. So when we look at the general settings, we actually have an installation script. So what this is it's actually something that you're going to run on the cluster, and actually gives you the ability to fire up what we use as a kite module within the cluster. So we're not a sidecar in every container. We're just a single small container that's running and monitoring those calls to kubedns to understand what's trying to talk to what, who's trying to talk to who within the cluster. Where we give you the option to, when you're doing discovery, to set the Kubernetes policy to allow all. So this is really allowing you to just create a very locked down version of your app. Set the policy to allow all, and then go ahead and test drive the application and see what it's doing, where it's talking, what its dependencies are. And then at that point, you understand what it needs. And then as you're working with your security analyst team, your network analyst team, you're able to actually say, all right, build this list, build that application architecture and what's necessary, agree on that, and then turn it into that immutable policy that you're deploying, that you're committing. When we look at the APIs and stuff like this is where we actually get into everything that we're doing with secure cloud. So there's a big public cloud portion of this as well, but we're focusing on the workload security portions of this. So we have all of the different schemas and things like this. So what this allows you to do is to actually close Slack here in a moment. Actually view these different rules. So one of the things that you see is the get network security policies, and it actually takes in the name of the cluster. So the name of my cluster is actually, I think I'm logged in on this one. So the name of my cluster here is retail. I picked my data and default namespaces in here, and I'm going to go ahead and execute on this. And what it does is it shows me the curl response, and it shows me the headers that I used in here. So you can see my token and all of these different things that went into that header. It shows you the request URL that I used in here, and then it shows me the response. So it gives me the response information and the ability to download the file. Now, if you use curl locally and you actually download the file, what it's going to do is actually download that file locally. In this case, you'll see it pop up that same Kubernetes network policy YAML file that I had downloaded earlier. So this is actually giving me that information in the same manner. And we give you all of the different response portions of this, so you'll be able to see if something's working, something's not working, if something's broken, and you can actually go through and understand clusters as well. See if there's if I want to delete a connection, I'm going to go type in here retail, the name of the cluster monitoring environment, and I can actually go through and delete my connections. And this would delete all of the connections for this cluster in there. So this is mapping back to that network cluster policy. So if I have a bunch of stuff and I want to just start from scratch, I can go ahead and blow it all away and start over and retest the application. And that's what's going to lead back to the refreshed network graph, everything like this. So as an example of when I look at this, I'm going to go ahead and I want to delete everything I'm going to look at my data namespace, filter that. And I see I have admin to Postgres in my data there. I'm going to go ahead and delete that rule, remove it. And now I have that portion of that is gone. So now if I go back and I actually, click on my view accounts, test drive the application again, and come in here, I can actually refresh and I'll be able to actually see in the cluster graph that it is attempting that communication again. So I actually have admin to Postgres is right here. And this is that connection. I'll see it in the new connections tab. It showed up, deleted it. I tested. It's right back there, showing me that, yep, I do have this dependency in this call. So that API call that we looked at here in delete actually goes through and deletes that whole application policy. So you can start over from scratch. I know I've gone kind of quickly through this. I'm going to go ahead and stop my share here for a moment and come back and check and see if there is some questions and stuff like this. Can we demo? So let's see. I saw there was a question in here. Can you demonstrate some API attack? Can you elaborate, Andre, on Andre, and what you're looking at there for an API attack? Is it are you demonstrating if somebody's trying to go like trying to hit your API over time or delete your policies? What that looks like, or how are we authenticating with the APIs? That kind of what you're looking for there. So I actually will be able to show you a little bit of that here. What we can do, I'll share the Chrome window again. So when we look at the settings themselves, one of the things that we'll have here is scroll down to my general configuration. We have the API access keys. So you actually have to have that bearer token in here. So if you look, we have many of them in here, and I think here's Ricky's demo key that I just created for this. We can go ahead and remove this access key right here. I'm going to go ahead and remove it. And now when we go through access key delete fail, I might have clicked it twice. I did. Yep. All right. So that access key is gone. So if I go back through here and I actually attempt to execute this, I'm going to go ahead and run this again in here. And I think I'm still authenticated. I'm going to authorize and go ahead and log out. Close this. I'll reauthorize. I'm going to put my key back in. Close that. It doesn't appear that it deleted my key. All right. So now that key should be gone, let's deauthorize. And we'll plug it back in. And hopefully I didn't copy somebody else's key. I didn't. Okay. So now when we go through and go to the cluster management and the traffic policies, and we want to get this information, we'll go ahead and plug this in, and we should execute this. And we have an error header in here. So you'll see that I actually am unauthorized in here. So it's actually kicking me out and not allowing me to go through. So my response error was that I'm blocked. And if we go back in here, we can actually go through the audit trail. And you'll see that I deleted my access key. It does not show that API access key being going through and actually looking at that, but it does show that I did, I deleted that access key in there. I will check and see if we can send that unauthorized API calls in there as well. I know there are some things we can do to actually offload syslog to your systems. So I will validate whether that is something that we can do. But without that actual token, I can't do anything in there. So it just gives me the unauthorized. So, okay, I see what you're saying. So suppose some attacker tried to enumerate your access keys. So how can you prevent that? So you're talking about being able to brute force the access key, and if they get it right, what happens, right? That is going to be that'll be one of the challenges that with anybody with that API, how can you block that? I don't have the exact details on what we can do there. But I don't know if there's a lock mechanism. Like there's so many tries from a source, we lock you for a period of time, etc. I don't know how we handle that on the back end. But that is a good question. We can definitely talk to our product team and get that information. All right. So I kind of blew through this pretty quickly, actually, like looking at what we can do there. Were there other questions and things like this that you guys wanted to get into or dig in? I know one of the things that we usually get asked is one of the things that we get asked is how easy is this to deploy? And the sign up takes a couple of minutes. You plug in your email address, company information, right? And it creates your account. And from there, you actually have 30 days free to go be able to test drive this. And that during that time, it's not like sales calls like, hey, we saw you do this. They give you a couple of weeks to actually be able to reach out. And we're going to reach out to you and check to see, hey, do you need any help? Do you need assistance? Do you need a walkthrough? And somebody from my team will actually be engaged with you to run through your application and understand what's going on. So they'll go through, hey, we see that you're doing this. You don't have vulnerability pulled in. Here's how, let's walk you through that and get that portion pulled in, etc. So the process actually looks like, hey, getting it deployed, things like this. There are other portions of the suite as well. So this is going to pull in, if it's OpenShift, if it's running in Tanzu, if it's running in GKE or wherever you're running your Kubernetes clusters, it's going to work there. The other portion of the suite that we look at is actually that we do have the public cloud portion as well. So we can pull in AWS, Azure, and GCP and actually understand your security policies within those environments as well. So you can compare, this is, I know I'm talking to this instance from my Kubernetes cluster. These are the ports and protocols, and then you can actually understand this is what my security policies look like on that cluster, on that instance that's running as well. So you're able to pull that information. And Arjun actually asked, is this a SaaS solution? And yes, this is a SaaS solution. We have talked a little bit about what it would take to be able to host it privately for somebody. So if you bring the right use case forward, that is something we would we talked about and discussed, and especially with like government type entities and things like this, it's something that we're actively investigating what it would take to run it privately or as an on-prem solution. All right. I, at this point, don't have a whole lot more to cover. I'm going to actually jump through and give a real quick look at what the public cloud portion of this actually looks like. So show the Chrome tab here and secure cloud. So security certifications right now, I would have to check. I believe we have some ISO certifications in there. I don't know the details of that. It's something in our sales process that typically our legal team shares that information with whatever clients need it. I could try. We would be able to track it down. I don't have that offhand. When we look at the other portions of the suite, one of the things that you do get to is a dashboard, so you can actually get a high-level quick view of your vulnerabilities. So you get your Kubernetes vulnerabilities. 0x2 clusters have known vulnerabilities in the clusters themselves. The workload security, 48 of my 51 workloads have a Potter security context in here, and you can actually see the container scores, whether it's A or A+, etc. in that. And then container vulnerabilities, 20 of my 51 workloads have an image score of B or lower, meaning they have more severe vulnerabilities. Permissive network policies. So 2 of my 2 clusters have permissive policies, which means they're wide open right now, really. And then CS benchmarks. So we also do the CS benchmark scoring. So if I look at the retail project as well, you can see that, ensure that the admission control plugin event rate limit is set, and it goes through the CIS benchmarks for configuration of the clusters themselves. So we're walking through that portion of that. We also then have the same thing for public cloud. So the CIS benchmarks for public cloud, permissive access, risky ports and protocols, tag usage, policy violations. So the same things when you're looking at policies in public cloud, we're doing the same things in Kubernetes. We're doing the same thing on-prem to be able to allow you to set those policies and then to measure what your actual rules look like against those policies. And this is something that's been a natural evolution from us from on-prem into the cloud environments as well. All right. And then that was all I really had to kind of cover today. So, kind of a shorter, brief session. So, I know we didn't go the full hour, but we did go a half hour. So we can give you some time back in your day. I'm going to go ahead and pull Cody back on so he can give the plug for TechStrong and the wonderful platform that they have here. I've told him several times how much I appreciate how well they do it. So very happy, and thanks a lot, Cody, for having me.
Thank you so much, Ricky. It means a lot to get such high praise. I just want to send a quick reminder to our audience that this session was recorded. If you missed any of it, or you just like to share it with somebody you like or love, the on-demand will be made available after the webinar concludes. Real quick, I just want to announce our winners of our $25 Amazon gift card drawing. Our first winner is Dewan A. Our second winner is Sasha S. Our third winner is Anna P. And our fourth winner is Enrico F. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't find an email, just check your spam folder. So Ricky, thanks so much for being here with us today, for preparing that demo. Do you have any closing remarks, anything that you'd like to leave our audience with before we shut down?
Man, the only closing thing I'll leave you with is something that I kind of evangelize, and that's do what you can to pull those teams, the network and security teams, pull those teams in and help them understand what you guys are doing as developers. Because at the end of the day, it's not that they don't want to help. A lot of times, like for me when I first started, it was technology that I didn't understand, right? And I'm kind of looking to you guys to help be shepherds and help us be successful.
Awesome. Ricky, thank you for taking the time to share your expertise with us. I'd like to thank Tufin for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us today for the entirety of the presentation. Please take a second to fill out our post-webinar survey and have an excellent rest of your day. This is Cody J. Brown signing off.